Hello, so this is the part 3 of a review of chapter 18, properties of determinant. So we'll move on to the last four of them. So let's kick off with the property number 7. So I think this is the most beautiful or interesting, important properties in this chapter. So I will give a heart there. So we'll see in a minute why. So all the triangular matrix, the determinant is actually just the product of the diagonal or the pivots. So let's say you have 4 by 4. Let me fix that. A, B, C, D, and this you have some asterisks, means some random number here, or if you have the transpose of it, like some random asterisk here, 0. So this will be the lower triangular, and this will be the upper triangular. So either of them will have the determinant of either the determinant of L or the determinant of U will be the product of the diagonal or the pivots. So it is A, B, C, D. So how can you get them, if you may ask? So again, we will use the previous property, which is the property number 3. But before that, of course, like we can do elimination. So eventually we can remove all of this, like the asterisk here, to 0 because of the elimination that we are really familiar with in the previous earlier chapters. So eventually this will become 0, and then what you can do is from property 3 you can pull out the A first. So you will have like this, and you have B there, C, and the D one here is 0, and then you can pull out the B again, and this will be 0, and then you can pull out the C, this will be 0, and you get the idea. So you're left with the A times B times C times D. Okay, so that's why I really like these properties, because it really simplifies the computation of the triangular matrix, either lower triangular or upper triangular. And actually this is also where this formula comes from. So let's do it this way. So let's have A, B, C, D, and we want to eliminate this component here. So we will multiply the second row with something which is ratio of C per A times A, and the component D we also subtract by something which is the C over A times B, and then so this goes to 0. And now we have the triangular, this is the upper triangular matrix here, and then we can just simply multiply these two. Okay, so let me bring it here. So A times D minus CAB equals AD minus CB. So there you have it. You know where this formula comes from now, which is, I think, really beautiful. Okay, so that's about properties number 7. Let me clear up some space here. And about the property number 8 and 9, actually I'm just gonna state them. Let's just have them as a statement rather than something to prove of. So number 8 says that if A is singular, then the determinant is 0, and if A is invertible, then the determinant of A is not equal to 0. So actually this also agrees with what we have been learning so far, that if A is singular, which will probably bring us back to the property where we have the row of 0, or maybe look like this. So this will be singular, so the determinant will be 0, and if not, then the determinant will not be 0. if it has another case of like full rank matrix, which is the invertible one. And regarding the property number 9, there is some proof in the book, and I encourage you to see that if you really love to. But important point here that I want to mention is that this is the first time that we see the multiplication property in this determinant. But remember this part. So remember that we don't have the addition property. So the determinant of a plus b is not equal to the determinant of a plus the determinant of b, but the determinant of matrix A times B equal to the determinant of A times determinant of matrix B. We do have the addition of rule, but only for each row. Remember, in property 3 we talk about that A plus AX and B plus BX and CD, and we keep the second row fixed, and then we can factor them out to this form right here. So we do have this one, but we cannot do them if they are doing the addition to all or multiple rows of them. So I'll leave it there. So properties 8 and 9. Property 8 talks about this: if singular, then determinant is 0. If not, then it's not 0. And property 9 just states that the determinant of AB times the determinant of A times the determinant of B. And actually property 9 has it brings us some new interesting property here, which is if I say that B is equal to A inverse, then that means the A times A inverse of course will be equal to identity. And if I do the determinant in both sides, then I will have kind of like this. So determinant of I will be 1, and this will have follow my rule of property 9, and I will have the determinant of A inverse equal to 1 over determinant of A. And also this another thing that will bring us is the if I just square a matrix, then the determinant will be like A squared. So the determinant of A squared equal to the determinant of A being squared because of this property. Okay, so let me delete these. And finally we are moving on to our last property, which is the determinant of A equal to the determinant of A transpose. So there's a little proof, a really quick proof. So if you remember how we factorize A is the lower triangle times the upper triangle. So let's also do that here. So if you remember, I'll just briefly review here. So the lower triangle is usually some kind of step of that elimination, you know, like you bring up the -1 of first row, and then you want to add them to second row, and it's actually like some kind of result that you have. So yeah, that's just a quick review. So you can factor out A into these two terms. So yeah, U is the matrix with all the pivots, and one step before the row echelon form, the one with all the pivots, but not that all clear yet. So that's just a quick review. So move on to this the proof of the property number 10. So we have it here, and we want to prove the determinant. So we just do this. We want to determinant of both side. This is actually equal to UTLT. Remember the transpose rule change the order, so we have this T, and then we use property number 10. UT times determinant of LT. Now, why I bring back that brief discussion there, because if you notice that the L and U are of course the triangular matrix, so this is like with all the pivots here, the U, and the L is some kind of this kind of matrix with all the pivots here and all the zero being here, and this is all the zeros being here. So they are in the end are triangular matrix, which bring us back to property number 7. And what I want to say is actually this term and this term, and then this term and this term are actually the same. So they both are the same, thus these two must be also the same. That's it, I guess, for the proof of property number 10. And then the last thing that I want to bring up is the last note here, which is there's nothing special about the rows, because we have been talking about rows so far, you know, for example, the AB, and we have the rows of 0, then the determinant is 0. But since we introduced this property number 10, we can also have this A, and we can inverse A into AB00. So actually the columns of 0 will also play an effect into how the determinant will result. So this will also equal to 0. So there's also nothing special about the row, and the rule also applies to the column. So that's the last point that I want to bring out. So that's it. Thank you.